So hi, how are you today? Uh, for something about me, uh, I'm Ivan. I'm working as senior software engineer, mostly with JavaScript. I'm working in a USA company called Welltalk, and you have my Twitter and website here. I usually write about microservices, micro frontends, and JavaScript in general. So let's start with this. First, let's remind of some good times when we were using Rails, PHP, jQuery. You probably remember those times. Then we also used Ember, Backbone, and Angular 1. So those are the languages that are probably dying now. We have some new frameworks. We have new versions of React, of Angular and React. We have Vue.js. We have Meteor, a bunch of new other languages and frameworks. But those things are still there as legacy projects, and probably many of you are still working with stuff you see here. I also work with many of those in my current company. And as everyone, we want to try new things. We want to explore some new frameworks, new JavaScript styles. And, and that's something that micro frontends can give us. So when you see a list like this is your reaction probably. And then the guys from the list have an answer for you. Yeah, they're still there. But as I said, now we have micro frontends, and we can start deprecating part by part. So when you think about micro frontends and killing all those guys from the list, your reaction is probably something like this. So let's start with the micro frontends. So what are the micro frontends? Micro frontends, that's basically a microservice approach on the modern front-end web. Everything we know about microservice, we can implement in the front end, and we can decouple our big application and introduce some new frameworks, new smaller applications in our front-end apps. So before we start with some examples, I see maybe some of you still don't know what are the microservices in general in backend world. So let's go through that first. So microservices in general, what are they? That's basically an architectural style where we have our application as a collection of loosely coupled services. Loosely coupled mean that every service is independent and it can work without knowing what's outside of the world. And our microservice application usually looks like this. So since we're using Node, we have some big application that's split inside some services. We here have 3 Node services. They can communicate together, exchange some data, and that's how our big app works. Usually, this looks more like this. We have some event bus, and we can exchange information between our services, and our services are independent, and they don't need to know anything about the other services. So what's the event bus? It basically allows us to have the publish-subscribe style communication between our microservices. And they are not required to register, so they don't need to know about each other. So let's go back to this picture and see what are the some principles around the microservices. So we need to have some lightweight protocol between our services, the, for example, HTTP protocol in backend or the event bus. We need to have small services, so as smaller as we can do, and we need to have 1 job per service. And services need to be independent, so each service can be developed and tested and implemented without knowing for the other services. And microservice architecture should help us to easier understand how our app works, and easier to develop the app and easier to test. It should also speed up development because we can easily share the work between teams, and every team can work on separate service. And we can do continuous delivery and deployment. That means that when each service is ready, it can immediately go to production, and it don't need to wait for some long builds of the monolith apps. So our 3 Node.js apps, when we look at this, and when we think about the front-end microservices, we can easily think about something like this. So our node services can be React. So our React app can be decoupled and served as many smaller React applications on one page. Or even we can do something like this. We can combine our frameworks. We can, for example, have the new version of Angular. We can have React. We can have Vue.js, or any other new framework that you like. So that's the magic of micro frontends. You can have your old monolith app built on Rails, for example, or on Java, and your boss probably is not allowing you to spend the whole year to rewrite that to Node and to use React there. But you can try with smaller parts. You can refactor some smaller features of your app and play with the new things. So when we have those 3 frameworks here, React, Angular, and Vue, we usually speak like Angular versus React versus Vue. But in the micro frontends, we can speak about something like this. We can ask, how can we make our new frameworks work together and get best of those 3 worlds? And in micro frontends, when you start implementing micro frontends, you're coming to this part. This is the fat guy here. That's usually me when I tell this to my friends. And this guy here is some of my friends. So when I tell them that we should have microservices everywhere. And usually the next question about the microservices and micro frontends is why to use micro frontends. So first thing is that you can use new front-end frameworks on your projects, on your big, large projects, without having to rewrite some of the old code. And that's really fun because every day we see some new library, new framework. You come to the conference, you hear for some new approaches in the front end, and then you go back to your company where you need to use Backbone. So this is what can help you to change that. You can go back to your company and then put something on top of the Backbone and play with that. Next thing is that when we decouple our front-end application, we can use separate repos in Git for the code. So we don't need to have the shared code bases anymore and conflicts. Every team can have their own repo, and they can work there, implement their own stuff. You can also have independent deployments. That means that you can put your apps on separate servers and deploy them when they're ready. And also the good thing is that every team can pick their own stack. So you can have you have company of 10 front-end teams where some teams use React, some use Angular, some use Vue, some teams use something else. That's basically what we do in Welltalk. And now that we know what are the micro frontends, what are some benefits of using them, let's see how can we implement that inside our apps. So far, I found those 3 different ways of the implementation. First one, I call that manual app fetching. There's no really a name for that, and you will see why. Next thing is iframes. So you remember the good old HTML iframes. You can use them to decouple our front-end apps and use microservices, micro frontends. And there is something new called single spa. That's the NPM module that helps us to use different frameworks on one application. And that's something really new, and it's really cool. So I will also show you that. So let's start from the first one, manual app fetching. So what are some features of this approach? Here, code is living on different server. So imagine that you have some big monolith app, and you want to add some some new framework on top of that, for example, React. You can just pick up a different server, create your bundle there, and your React app will live there, but will be served on your monolith app. That also means that you will do independent deployments. And when you're done with some React feature, you don't need to start a 3-hour-long build of your monolith app. You will just need to redeploy your React app, and the changes will be there. And the communication between app services on the front end can be done using the window object. Window object in browser is visible everywhere, so you can put some variable there, and every other service will be able to read it. Or you can use event bus. There is also a front-end implementation of event bus, and I will also show you how that looks. So let's see the code for the manual app fetching. This is a function that I called FatTrap. It's just one function that you need to implement inside your big application, and that will allow you to fetch any separate service and render that on your page. So this FatTrap function is really simple. It requires an object with the element that's basically some ID or class of a div where you want to render your micro app. It requires the base URL, the URL where your micro app is living, and the files that you want to download. So it's usually just bundled main.js and main CSS that you need to download. And it also gives you the ability to pass any other file that you have. Expect those main.js and main CSS bundles. So let's just explain how this function works. We have the function name at the top. That's basically we just remove the hash or a dot from a string of the element that's needed to find the function on our micro app to initialize it. And let's zoom here a bit. So this is the main part of the function. We just go through all those files that we want to fetch, main CSS and main.js. And depending on the file extension, if it's CSS or JS, we download that on a different way. Here I just used the good old jQuery. If it's a JavaScript file, then we are just downloading the JavaScript code, and we are injecting that directly on the client side. And we have this done callback. We are, as you see, the function name. For example, if we want to render our app inside hash app div, the app name will be just app. So the global function named app will be called here, and we will pass the string element where we want to render that. And the global function will come from our micro app. I will also show you how's that working. And for the CSS, we just append the CSS link in head, and that's basically it. Our app will be able to render. That's everything what we need to do on a main app side. For our micro apps, for example, this is one React app, nothing special there. We just rendered the H1 element with text hello. We're using React DOM render to render that inside the DOM. And we are exporting this default function that should take the element string, basically where to render, and send that to a render function, so our micro app will be able to render anywhere where we want. And inside the main.js file that we export, we need to do something like this. So remember, this global app will be called here on done. So we will call global app, pass the element, and that's how we connect the main app and the micro app. So at the end, it looks like this. Just import the FatTrap function, and you can pass any element and any base URL. From this base URL, we will fetch main.js, main CSS. We will inject that in our in the UI, and when the DOM is ready, this will be executed, and your user will immediately see the micro app. You can use this FatTrap as many times as you want. It's really simple, and just don't make so many front-end services. So I said that we also have the front-end event bus implementation. I really like this EEV module. It's not so popular, but it's so small, and it's so simple. It has only, I think, 80 lines of code, so you can even read and see what's happening there. You can find that on a GitHub, and there's also an NPM library. It's really fast. I've tried that with let's say 50 services, and they were exchanging information. So when one service sends a message, all other services that are listening for that message are getting the message immediately. So it's really cool, and it's happening on the client side. This library has 0 dependencies, so just one integer.js file with 80 lines, and it's simple to use. It's something like this. So this is the whole implementation that you need to have inside your app if you want to use EEV. Just import it, initialize it, and just use those two emit and on functions. The emit function is sending the message to event bus. You need to pass the message name and the message body, some object, some data that you want to send. And you can also listen for that event on the other service. You can pass your callback function, and the data will be there when the first function sends it. So in this example, we are sending the foo bar, and you see here when the event is sent, we are reading that and putting it in the console. Pretty simple. And if you want to share the instance of the event bus service, I recommend just putting that inside the window object like this. So you will always have your window.e instance of event bus there, and you can use that in any service that you put there. So this is one way of implementing the micro frontends. Let's go to the next one, the iframes. So some features of the iframes, the same thing as the manual app fetching. Code is still living on a different server. So you also need to spend some money to have a couple of servers for your micro apps. You can also do independent deployments. And the communication between the main app and the iframe is done through something called browser event bus. That's not really an event bus, that's just a message system that every browser has, and it allows us to send a message between an iframe and the parent app. So that looks like this. Inside the window, we have this postmessage function, and we can send any data we want, so any object, array, whatever. And we need to specify the origin, so the origin is the URL of the web page that's living in iframe. So that's it. Yeah, when we call this the iframe with, for example, example.com, we will get the data. And inside the iframe app, we needed to put something like this to listen for the message. We will have this receive message callback that will be called when the message is received. And let's see some implementation of that. Here we have the simple HTML page with an iframe and with some JavaScript code. At the bottom, you see we are calling some iframe with https example.com/app.html and with the ID app iframe. And we have some JavaScript code here, so let's zoom that. This JavaScript code is just looking for the iframe and sending some message to it. We are making a constant app where the content window of the iframe is living. And we can use app.postmessage to send them some message there. There are two examples. The one with the google.com origin, that won't work. You will have an error in your console because the real origin is example.com, so the second function will work. And also, the parent component can receive a message from the iframe. So there is the code for that below. We have the event listener for a message, and we have the receive message function. So first, we need to check if the message is really coming from the iframe, from the correct origin. If not, then just stop execution of the function, and we're just logging the source, that's the iframe, and we're logging the data. So that's hi from an iframe. That's a string that will be sent from the iframe. And this is the code that's living inside the iframe. Inside the iframe app, we also have the event listener, and we have the same check for the origin, just in case, just in some security case, we want to know that every time the message is coming from our parent app. So here we also log the source. It's window.opener. That means our parent app, the app that opened the iframe. And we are logging the data. This will work hi there. Inside the event.source, we have the reference to our parent app. So we can use postmessage there to send the message back to the parent app. And this is basically the way how we can use iframes to implement micro Frontend architecture. Then let's go to a third example, single spa. This is my favorite kind of implementation. The single spa is an npm module that's living on GitHub. It's used by a couple companies. It has a lot of contributors, so you can check it out there. What are the main features? You can easily use multiple frameworks and bundle them inside one main.js file. And it's so easy to use that, and it's really simple then to have just one bundle with all your frameworks and do the deployment on just one server. If you already have some app in React, for example, if you already migrated from the old PHP or Rails full stack monolith apps, and you have split your front-end and back-end parts, you have some Angular React front-end, you can easily just reuse that code, implement the single spa, and then just add some new components there, some new micro front-end components. And there's also lazy loading implemented, so your bundle won't be loaded all at once. It will be loaded separately, depending on the page or any condition that you posted there. So here, the code is now living on the same server, so that's always good to have just one bundle file, and everything is bundled and deployed at the same time. You can still have your code living on different repos, and then have just some continuous integration service that will pull all your code from all repos, bundle that, and deploy on one server. We have a bunch of different ways to do communication between the services here. We can always use the window object. We can use EEV event bus. We can now introduce something new, like Redux. We can have the shared state between our services. For example, our main app can have the Redux store running, and then every other app can connect to that and send some actions there. That's something I want to recommend to you, because the microservice pattern is telling us that every service should have its own state, should be separate and independent. But if you want, you can use Redux here, and also you can use whatever else works for you, because you can easily here, since we have one bundle, you can easily share instance of anything you want between the services. So this is how it looks. The main application in single spa is called single spa config. So that's that's always running at the top, and that app is calling other services. So we are importing the single spa. We have couple of those functions here, and at the end we call single spa start. So let's go part by part here. Every application that you want to put inside single spa needs to have its name, the loading function, and the activity function, and we need to declare child application. So let's go from the loading function. What's that? It's function that is just importing the JavaScript code for your micro app. It's used for lazy loading. You're not importing it directly. There's just a function. So single spa knows how to call this function when your micro app is needed. We have the activity function. It's basically a condition when you want your micro app to be shown on a page. You can use history API. There's the location argument that's coming there. So you can check, for example, for a hash inside the URL. So if you have like example.com, and then hash /app1, then the app1 in single spa will be rendered. You can also put any other condition here. For example, you can listen for a window scroll. So if you have some micro app that's living at the bottom of your page, you won't load that until the user scrolls at the bottom of the page. Basically, you can do anything here. And the activity function must return true or false. So you can do anything. And the third thing we need to do is to declare the child application. We are passing the app name, we are passing the loading function, and the activity function. If you also want, you can pass some props as a fourth parameter in this function. So if you have your Redux running, you can pass, for example, the Redux instance here, and then your app will receive that as a prop. And we need to start our single spa app. And that's basically it. This will just work. How's the single spa application looking? So you're writing your regular Angular, Vue.js, or React app. And you need to provide one file to the single spa. And that file should export those three functions, Bootstrap, mount, and unmount. Every of those functions will receive props. The props is that fourth parameter that you can send in declare child application. And every of those, so Bootstrap, mount, and unmount should return a promise that's resolved. And inside that promise, you can do basically anything with the DOM. For a Bootstrap, this is one example of that. At the top, we just make a DOM element variable where we are storing the instance of our app. And inside the Bootstrap, we are resolving a promise. We create a div element inside the DOM, add some ID to that div, and we're saving that div inside the DOM element. So we would know where to render our app at the next steps. So this is the Bootstrap. Yep. Okay. Sorry for this. Okay. The Bootstrap, that function is called on a single spa start. So in that function, we basically prepare the DOM for rendering our micro app. Second function is mount. So now we have our DOM element variable. We can put anything inside. So here I'm just putting some text here. But basically, we can render React app inside, Angular app, any other app. And the third one, the unmount, that's happening when the single spa wants to unmount our app. It's asking us how to do it. The single spa is also coming with a couple more modules for React, for Angular, for Vue, for many other frameworks. And you see the fourth import here is single spa React. That's a helper function that's helping us to generate those Bootstrap mount and unmount functions easily for our React app. So the only thing that we need to provide is React DOM, our root component, and the DOM element getter, the function that will return the DOM element where we want to render our app. And we will receive the Bootstrap mount and unmount functions. Same thing for Angular. It's a bit more complicated, as Angular is. We need to provide a couple more things like router, template, Angular platform, the main module that we want to render, and same thing, DOM element getter. And we will receive the Bootstrap mount and unmount function. And for the Vue.js, it's the simplest. So you just provide the template and the element where you want to render your app in the DOM, and you receive Bootstrap mount and unmount. So that's basically it for the single SPA. It's really, I think, the coolest and the most JavaScript way to do the micro frontends. But when you don't have those abilities to bundle everything on the front end, where you have the old monolith app, the first two implementations are also good. So we are almost at the end. Who's really using this micro frontends? I mean, not sure if everyone here is using that. Yeah, there are people using. Cool. There are companies using that. I know that, for example, some freelancing site apps are using. I know that Egghead is using. There's the Europe company called Zalando. Yeah, you probably have heard for that company. They have big e-commerce app, and they're using a lot of micro front-end implementations to test some new features. You can just change some features in the app, rewrite that in React, serve that to 50% of the users, and you will see their reactions. And also in Welltalk, we started to use this about one year ago because we at the start we had just one big Rails app, and we wanted to use Angular and React. We want to have some dynamic UIs. So the easiest way was just to go with the first approach. We just have this FatTrap function. We are serving the apps, the front-end apps on different servers, and our React app is just fetching them and rendering depending on the page. And the conclusion, so some things that you shouldn't do and how to do that properly. So if you have some simple app, if you already use React and you have like 10 pages, you don't have so many interactivity there, just don't go with this because it will be over-engineering. If you're, for example, the only person in the team, and if you're happy with your approach, and there is no big need to do that, maybe you'll just over-engineer. But if you want to try something new, then definitely go with this and put something on the top of your app. Use micro frontends to make things easier. So don't over-engineer, don't make things complicated. Use this to make things simpler and to have more fun with the front-end application development. And micro frontends also doesn't mean to use every new framework in the world. So when you, for example, read the Hacker News, you see something.js that came up. You don't really need to put that on inside your app. And don't forget to make standards across your repos and your development teams, because your teams can use anything, but have at least the same ESLint configuration. It will make things easier, and developers who jump around the teams will know what to expect in the other teams. And that was everything from me. Thanks a lot. Yeah, I'm not sure if we have enough time for questions.
Just one question.
Yeah, one question. Yeah, there's the guy. Hey.
Hi. Hi, I have a question. Thank you for the speech. One question, one specific question. Have you tried to inject or to combine real Angular application and real React application on one browser application?
Yeah, I mean, that's what are we doing in Welltalk. Since we started with this one and a half year ago, I wasn't in the company, so there were mostly Angular developers, and they started with the Angular apps.
Yes.
When I came here, we started with some React apps. So right now we have a mix of some React and Angular features in our app, and they're communicating using the event bus. So it's fun. Yeah.
Okay, it was Angular 2 or 4?
I think it's 1.
It's new. One.
It's the old one.
Because if you try to inject Angular 2, Angular 4, so now it's called just Angular, then you will, I think you will have great problems with Zone.js and rewriting of set interval, set timeout, and lots of features. Because Angular 2 runs your digest on all browser-specific calls of like set interval, all fetch calls are interrupted, and so on. So React application could be broken in general.
Yeah, I mean, I'm writing a book about this. So I was playing with the Angular 2 and React.js. I was making some simple stuff. I can show you that later if you want. But I didn't have problems. Maybe when you come to some advanced features, you will have issues. I really don't know. But the single SPI is helping with that. You can decouple and make your Angular and React app independent, so they can work separately.
Okay.
And there shouldn't be conflicts, but probably they can be.
Okay, thank you.
Thank you very much, Ivan. Thank you for coming. This
That's it.
was for you.
Oh, thank you. Thanks. Thanks, Jan. I hope you like it.